Carbohydrates. Objective of the study. What are carbohydrates? Carbohydrates are a group of naturally occurring carbonyl compounds that also contain several hydroxyl groups. It may also include their derivative which produce such compound on hydrolysis. They are the most abundant organic molecules in nature and are also referred to as saccharides. The carbohydrates which are soluble in water and sweet and taste are called sugars. Physical properties of carbohydrates. Stereoisomerism. Compounds sharing the same structural formula but they differ in spatial configuration. Example, glucose has two isomers with respect to the penultimate carbon atom. They are D-glucose and L-glucose. Optical activity. If it is the rotation of plane polarized light forming positive glucose and negative glucose. Diastereoisomerism. If the configurational changes with regard to C2, C3, or C4 in glucose, example, mannose and galactose. Anomerism. It is the spatial configuration with respect to the first carbon atom in aldehydes and the second carbon atom in ketosis. Chemical properties of carbohydrates. Ozone formation. Ozone formation are carbohydrate derivative when sugar are reacted with an excess of phenylhydrazine. Benedict test. Reducing sugar when heated in the presence of an alkali gets converted to the powerful reducing species known as N-joules. When Benedict reagent solution are reducing sugar are heated together with the solution changes color to orange red or brick red. Oxidation monosaccharides are reducing sugar and their carbonyl group oxidized to give carboxylic acid. Reduction to alcohol. The group and open chain forms of carbohydrates can be reduced to alcohol by sodium borohydride or catalytic hydrogenation. The products are known as alditols. Structure of carbohydrates. Carbohydrate is consist of carbon, hydrogen, and oxygen. The general empirical structure for carbohydrate is CH2O. They are organic compound organized in the form of aldehydes or ketones with multiple hydroxyl group. The carbohydrate can be structurally represented in any of these three forms: open chain structure, hemiacetal structure, Howard structure. An open chain structure is the long straight chain form of carbohydrate. Hemiacetal structure are the last carbon of the glucose condenses with the negative OH group of the fifth carbon to form a ring structure. Howard structure, it is the presence of the pyranose ring structure. Classification of carbohydrates. Carbohydrates have monosaccharides, disaccharides, oligosaccharides, and polysaccharides. Monosaccharides is consist of glucose, fructose, and galactose. Disaccharides are consist of sucrose, lactose, and maltose. Oligosaccharides consist of raffinose and stachinose. Polysaccharides are consist of starch, glycogen, and cellulose. Monosaccharides. are the simple group of carbohydrates and often called simple sugar since they cannot be further hydrolyzed. Colorless crystallized solids that are soluble in water and insoluble in a nonpolar solvent. These are compounds that possesses a free aldehyde or ketone group. They are classified according to the number of carbon atoms they contain and also on the basis of the functional group present. Monosaccharides have 3, 4, 5, 6, 7 carbon are called triosis, tetrosis, pentosis, hexosis, heptosis, and aldosis or ketosis, depending upon whether these contain aldehyde or ketone group. Example of monosaccharide are glucose, fructose, erythrulose, and ribulose. A disaccharide is the sugar formed when two monosaccharides are joined by glycosidic linkage. Like monosaccharides, disaccharides are a simple group sugar soluble in water. Three common examples are sucrose, lactose, and maltose. Disaccharides are one of the four chemical groupings of carbohydrate. Polysaccharide, also called glycans. Polysaccharides contain more than 10 monosaccharides units and can be hundreds of sugar units in length. They yield more than 10 molecules in monosaccharide on hydrolysis. Polysaccharides differ from each other in the identity of their recurring monosaccharides unit and the length of their chains and the types of bond linking units and in the degree of branching. They are primarily concerned with two important functions, structure function and the storage of energy. Example are starch, glycogen, cellulose, and pectin. Oligosaccharides are compound sugar that yield 2 to 10 molecules of the same or different monosaccharides in hydrolysis. The monosaccharides unit are joined by glycosidic linkage. Based on the number of monosaccharide units, it is further classified as a disaccharide, trisaccharides, tetrasaccharides. Oligosaccharides yielding 2 molecules of monosaccharides or hydrolysis is known as disaccharides, and the ones yielding 3 or 4 monosaccharides are known as trisaccharide and tetrasaccharides, respectively, and so on. Example, disaccharides include sucrose, lactose, and maltose. Function of carbohydrate. The four primary functions of carbohydrate in the body are to provide energy, store energy, build micromolecules, and spare protein and fat for the other uses. Glucose energy is stored as glycogen, with the majority of in the muscles and liver. Purpose of carbohydrates. Carbohydrates provide the body with glucose, which is converted to energy used to support bodily function and physical activity.
General reactions of carbohydrates. Molesch test. Molesch test is a test which determines the presence of carbohydrates in a solution. Pipette 2 ml of each solution into labeled test tubes. Add 2 drops of Molesch reagent. Shake the contents well. Add 1 ml of concentrated H2SO4 slowly under the fume hood. You will be able to see purple or violet ring. That means Molesch test is positive, and that means there is a presence of carbohydrate in the solution. Bayes test. Bayes test is the test which distinguishes pentosis from hexosis. Add 8 drops of the sugar solution. Add 1 ml of Bayes reagent. Mix the contents well and heat for 5 minutes in a water bath. Blue-green color arabinose means Bayes test is positive. Yellow color in glucose solution means Bayes test is negative. Seliwanov's test. Seliwanov's test is a specific test for detecting ketose sugars. Pipette 5 ml of each test solution. Add 1 ml of Seliwanov's reagent. Mix well and boil for 5 minutes. The red color results indicates positive Seliwanov's test. Pink color means negative.